Hello guys, so here I have hello, by the way, welcome back to Manala's Arc. I forgot my greeting there. Here I have a trig in Cartesian plane and I'm solving a question paper from November 2018. This was a national exam and obviously it's our country, right? South Africa. So now here we have question 3.2.1. Let's get straight to the juicy part, right? In this situation, I want you to understand that every time, okay, I'm rushing things now, I'm too excited. It says coordinate S has -3 and -4 as its coordinate, as its values. So this is a point on a Cartesian plane such that OS makes an angle of theta with the positive axis. Right, that's a reflex angle, right? Now, the first question here, it says calculate the length of OS, right? OS, it's like this from this point here up until this part here, the distance of that, right? Now, I want you to understand that here, the best thing to use specific for this topic, I'm sure you have this other idea in mind. I won't say it because I don't want to validate it. What we prefer in this topic is for you to use trig, right? But yeah, just use what you can think of at the moment. But if you're thinking of trig, then good idea. When you have a terminal like this, first of all, you want all terminals to form a right angle triangle with the x-axis. That's what you want, right? And then now here, this coordinate is in the form of x and y, which means the first value is x, which means the distance from here up until there, that is at -3, right? And then the second value, it's the y value, which means the distance from here up until there, that goes up until -4, right? So you have an x value, you have a y value, right? Y value here, x value here, right? Which means now if you have to find OS in a right angle triangle, that's easily Pythag, all right? So we are saying OS, the square of OS is equals to x squared plus y squared, and that is Pythag, right? Which means now OS, if I remove the square, is equals to x squared. Put this properly. If I remove the square in this situation, I'm going to have plus minus the square root of x squared plus y squared, this way, right? So now OS will be equals to plus minus the square root of, what is my x value? My x value is -3, I squared it. What is my y value? My y value is -4, I squared it. Right, let me quickly take out my calculator so that I don't waste time. Remember, in the exam, time is the most precious thing there. Pull out my thing. I have -3 squared. Let me put the negative so that you guys don't complain. -3 squared plus -4 squared under a square root, that is 5. Easy, right? So which means my OS is equals to plus minus 5 units. Now, is this value positive or negative? You're going to say, but R is always positive. Your distance is always positive, guys. So whenever you're calculating distance, the distance is always positive, and the hypotenuse is always positive. You're going to say, therefore, your OS is equals to +5, and your OS is not equals to -5. Right? We are done with OS there. We're good. So we just found OS to be equals to +5. Let me write it here. I think I might need it here. Let's put 5 here. This one is -3. This one is, and this part here is -4. Let me write it this side so that we can see it. We're good. So now to the next question. Let me erase here so that I get some space. Now, the thing about trig on a Cartesian plane is that it gives you trig expressions, right? Things like this situation here. This situation, we call it a trig expression, right? that's the thing about trig. Trig has too many topics. It has trig equations, trig expressions, trig graphs. When you get to grade 11, you'll learn about general solutions and things like that. Trig has too many topics, right? So now, here we see we have a trig function that says sec, which is a second. Now, which means we need to go back to our trig functions now and remind ourselves of their inverses. Now, what are inverses made of? Inverses are made of cosines. Let me see. Like for instance, this one, it is the what? This is the cotangent. Cotangent, which is the cot, right? Cot. This one, it is supposed to be a sine. So when you put a cosine to it, it becomes a cosecant. Cosecant. See here. It becomes a cosec, right? And this one is a cos. So an inverse of a cos is a secant, which is sec, right? So this situation here, we have an inverse of a cosine. Now, what is a cosine made of? A cosine is made up of adjacent over hypotenuse. The inverse of that now is made up of hypotenuse over adjacent, which means here I'm going to substitute hypotenuse over adjacent plus, and then here I'm going to the sine. The sine is supposed to be squared, so I'll put everything inside the bracket, then square it. And what does the ratio of a sine compare? It compares opposite over hypotenuse, right? So, and then here I just do my substitutions. What is my r? My r is 5. My x is how much? My x is -3 plus my y. What is my y? My y is -4 all over my r, which is 5. I square that. That gives me 16 over 25. And to be honest, here you can just, obviously they'll say without a calculator. Okay, let me do it without a calculator. Right, the LCM of 25 and 3, what do they have in common? I think that's 75. Yeah, I think that's 75. So I'm going to say 5 over 3 plus 16 over 25. I make denominators the same, so I'm going to say multiply this side by 25 over 25, multiply this side by 3 over 3. Now that gets me where? That gets me to 25 times 5, which is 125 all over 75 plus, and remember this is negative, so I put a negative above there. Remember this negative sign here. The negative sign belongs to the numerator. Let's put it there, right? And then I'm having plus, I have 16 by 3. That is 16 by 3. That is 6, 12, 18. Carry 1. That is 1, 2, 3, 4. That is 48, right? So this part gives me 48 all over 75, right? Now I have 125 minus 48. That is 125 minus 48. Borrow 1 here. It becomes 15 this side. 15 minus 8, that is equals to 7. And then here I borrow 1, so it's 11. This part here becomes 7. So I have 77. This is equals to 77 over 75. That's the answer I'm getting there. That's the final answer for 3,2,2. 3.2.2. Yes. I don't know why I said comma. So please like the video if you this was helpful for you anyhow. Don't forget to share the video to anyone who's doing grade 10, and hope all is well. See you on the next video. Don't forget to subscribe, and goodbye for now, guys.